Hi there, welcome to this video. I'm going to go through some questions to help you with some revision over the Christmas holidays, getting ready for the mock exams next term. In this video, I'm starting with some pure questions, then there's some stats and some mechanics. If you want to go to a particular topic, just look in the description as I've included some timestamps so you can just use them to go to a particular topic. So here we go. This question is all about base 3. So just rewriting the 9 as 3 squared, and that's to the x minus 1 all over 3 to the y plus 2 is equal to 81 is 3 to the 4. Multiplying these two together, so you've got 3 to the 2x minus 2 all over 3 to the y plus 2 is equal to 3 to the 4. Then taking these away and equating it to the 4, you've got 2x minus 2 minus y minus 2 is equal to 4. Take that y to the other side because it says express y in terms of x. So here you're going to have 2x minus 4 on this side, and then when that 4 goes on the other side it'll be minus another 4, so it'll be minus 8 is equal to y. This next question is this function here, which we can see is top heavy. If the powers on the x are the same, it's deemed top heavy. Now you can either do some partial fractions or you can just do the algebraic division. So when we do say 4 into 14, it goes 3 times remainder 2, so that's 3 whole ones and 2 quarters left over. You've got 2 parts of the next set of 4. So we just do that with the algebra here. We've got 2x plus 3 into 8x plus 5. Taking the 2 into the 8x, that gives us 4. Timesing that on the front in order to get our remainder, that's going to give us 8x plus 12. We do a takeaway, 5 take away 12 will be minus 7. So this goes 4 times minus 7 over 2x plus 3. So the A in the front is a 4 and the B is a minus 7. If you wanted to do it the partial fractions way, you could say 8x plus 5 over 2x plus 3 is equivalent to the A plus B over 2x plus 3. Go clear of fractions by multiplying throughout by the 2x plus 3, the denominator. You'd have 8x plus 5 is equal to A into 2x plus 3 plus the B. Now we can see the only way to get 8x here would be if A is 4, which we've got here, and then equating the numbers, we've got 5 here is equal to 3a plus b, and if b is 4 again, 5 will equal 12 plus b, so b again is our minus 7. Next, we've got some algebraic fractions, and we can see we've got a common term in the denominator. So all we need to do is make this one have an x minus 3 on the top and on the bottom so that we'll have a common denominator. So we're going to get 3x minus 2 into x minus 3 all over that common denominator of x minus 3, x plus 6. Multiplying this out, don't forget that this minus belongs to 2, so we need to multiply that out and get 3x minus 2x, but then plus 6 all over our x minus 3, x plus 6. Tidying up on the top, we've got an x plus 6 over an x minus 3, x plus 6, and then that term on the bottom can cancel, so we're just going to be left with 1 over x minus 3. A curve is strictly increasing when the gradient is going uphill. So if we do dy by dx and make that bigger than 0, we're going to get 6x squared minus 4x minus 2. That has to be bigger than 0. I can see I've got all even terms, so take a factor of 2 out. Have 3x squared minus 2x minus 1. Now this factorizes 3x and x, I need signs to be different, but I need a 1 and a 1 to make that one. I need more negatives, so if I make that minus and that plus, that will give me minus 3x and plus 1x, and those two together will give me the minus 2 in the middle. In order for that to be bigger than 0, if I just look where it equals 0 to give me my roots, that's going to be when x is equal to minus a third or x is equal to 1. So if I drew the graph of this gradient function, would go through minus a third and 1. And I want, where is this bigger than 0? It's going to be where x is less than minus a third or x is bigger than 1. It's very important to put that word or, because you can't be both those regions at the same time, so don't put the word and. And if you had to do that in set notation, you would write x such that x belongs to reals and x is less than minus a third. And then you would union that with x such that x belongs to reals and x is bigger than 1. In this next question, we're asked to find the positive integer k, which is part of the equation of the tangent to this curve, and we're told that p has an x coordinate 4. So what we need to do is find the corresponding y coordinate by subbing 4 into the curve, and then differentiate the curve and sub 4 in to find the gradient of the curve at that point, which will also be the gradient of the tangent. So when x is equal to 4, y is equal to 1/3 times 4 squared, that would be 16 over 3, minus 2 times root 4, which is 2, so it'll be minus 4 plus 3. So y is equal to 16/3 minus 1, which is 16/3 minus 3/3, which is 13/3. So that point there is 13/3. Now if we set y is equal to 1/3 x squared minus 2x to the half plus 3, and now differentiate it, power down, it's 2/3 x, and then the half, when it powers down, will cancel with the 2 and we'll get minus x to the minus half, taking 1 off, and we can sub in x equals 4 into that. So we're going to get 2/3 times 4, which will be 8/3 minus 1 over the square root of 4, which is 2. Let's turn that into 6. So it's 16/6 minus 3/6. So that is now 13 over 6. So using our y minus y1 is equal to rm into x minus x1. If times throughout by 6, you're going to get 6y minus 26 is equal to 13x minus 52. Take everything to one side to make the 13x positive, so send them to one side. You're going to get 13x minus 6y. This minus 26 on the other side will be plus 26, and if we join that with the minus 52, we're going to get minus 26. Now I've already got a minus there, so the actual k is going to be 26. This is part B of the same question, where we've just found k was 26 and we're being asked to find this area R. Now we know that P here, the x coordinate is 4. If we integrate between 0 and 4 of the curve, it will find us all that area, and then all we need to do is take away this triangle. So first of all, let's integrate between 0 and 4 of the curve, which is 1/3 x squared minus 2x to the half plus 3. So integrating, you're going to get x cubed over 9 minus 2x to the 3 over 2 divided by 3 over 2, and then the 2 on the front will times with this 2 and make 4 plus 3x, and that's between 0 and 4. Subbing in the limits, 4 cubed 64 over 9 minus square root of 4 is 2, 2 cubed is 8, and 8 times 4 is 32 over 3, and then plus 4 times 3 is 12, minus, put in the 0 in the bottom limit, that's going to be 0. So this is the area of the curve, and we'll need to take away the area of that triangle. We know that that triangle here is 4 along on the x-axis, but we need to know what that value is there. We know from part A that this was 13 over 3, so we're just going to do half base times height. But what is this point here? It's when we make the y coordinate here 0, so 13x minus 26 will equal 0. 13x is equal to 26, x is equal to 2. So this is a triangle that has a base from 2 to 4, so 2, and height 13 over 3. So the area of the triangle is going to be half times 2 times 13 over 3. Cancel those 2's, and if we do 64 over 9 minus 32 over 3 plus 12, and then take away the area of the triangle, you put all that in your calculator, you will get 37 over 9. In this next question, we've got this curve which is modelling the speed a car goes between two sets of traffic lights. So the speed is 0 here at the beginning, and then by the time it goes through the lights, the speed again is 0 at the second t. And that's the t we're being asked to find. Find the value of t, which is the time it takes between the two sets of lights. We're given this equation here, so if we equate that to 0, because the speed is going to be 0 when we are stopped at the lights, and we can see that it's a product of two terms. So if we say 10 minus 0.4 t is equal to 0, or the ln of t plus 1 is equal to 0, and just solve for both of those t's, we can see in this case, if t is equal to 0, then the ln of 1 is equal to 0. So that is the first place where the car starts at the first set of lights. So the t we're after is when we solve this second one. And so if we say 10 is equal to 0.4 t, so 10 divided by 0.4 is equal to t, which t is then going to be 25. It's in meters per second, so it's 25 seconds. This is part B, where we're using this equation to model the speed a car goes between two sets of lights, and we're being asked to show that the maximum speed of the car occurs when t is equal to this. Now we can see, because we've got a curve, the max is going to occur here where we have a gradient of 0. So we differentiate and equate it to 0 and try and solve for that t. So dv by dt, we can see we've got two terms being multiplied. We're going to use the product rule. So it's first differential of second. Differential of ln of t plus 1 is just 1 over t plus 1, plus second ln of t plus 1. Differential of first, which is minus 0.4. Equate that to 0 at the max. And then this negative term, let's take it to the other side. 10 minus 0.4 t over t plus 1 is equal to 0.4, the ln of t plus 1. If I divide through by 0.4, 10 divided by 0.4 is 25, and then minus t over t plus 1 is equal to the ln of t plus 1. Now if I cross multiply, because what I need to do is make these t's the subject. I can see where I'm going. I need to keep the ln of t plus 1, so I need to sort these t's out. So if I say 25 minus t is equal to t plus 1 into the ln of t plus 1. So when you multiply both of those in, you're going to get an ln of t plus 1 and a t ln of t plus 1. I want to get all the t's to one side, so I'll take that t over and bring the term that doesn't concern t to this side. So I'll get 25 minus the ln of t plus 1 on the left, and then take t out as a common factor, I'll get 1 plus the ln of t plus 1. And then just making this t the subject, I'll have 25 minus the ln of t plus 1 all over a 1 plus the ln of t plus 1. Now, what I can do is, if I make this 25 a 26 minus a 1, put brackets there and say that's plus the ln of t plus 1. So when that minus goes in, it'll give me a minus 1, which will make the 26 25, but it will also make that term minus all over the 1 plus the ln of t plus 1. Then I can see I've got the same denominator here as here, so these two terms on the top I can just split up and say I've got 26 over 1 plus the ln of t plus 1 minus 1 plus the ln of t plus 1 all over 1 plus the ln of t plus 1. So of course this bit here is just 1. So I've got 26 over 1 plus the ln of t plus 1 minus 1, which is now of the form that I'm being asked for. So A is 26, B is 1, and C is minus 1. In this next question, we're being asked to write sec x as 1 over cos and differentiate it and find what this a is. So if we write that sec x is 1 over cos, which is equal to cos to the minus 1 of x, then d cos to the minus 1 of x by dx means we've got to differentiate. Now we're going to use the chain rule. It's a function of a function. We deal with the outside function first. So power down, it will be minus cos to the minus 2, taking 1 off x, then differentiation with respect to the inside function, which was cos. So the differential of cos, which will be minus sine x. So the two minuses will cancel and we'll get sine x over cos squared x, because that is to the minus, so we'll just put that underneath. So that is sine x over cos x times 1 over cos x, which is tan x sec x. In this next question, we've got to show that this identity works, and you can start with either side. I think I'll start with the left. Cosec theta is 1 over sine theta minus sine theta. Making a common denominator, we'll have 1 minus sine squared theta all over sine theta, which will be cos squared theta over sine theta, which is cos theta times cos theta over sine theta, which is cos theta cot theta. This next part is following on from the identity that we've just proven, so that we can see we've got the same setup here with these x instead of thetas, but here what's in the bracket here must be the same as this x. These two have to be the same for it to equal the left hand side. So we start by saying that x must equal a 3x minus 50 and just solve for that x. So take that x to this side and the 50 to the other side. 50 is equal to 2x, so x is equal to 25 is one solution. Now, if we think of the cot graph, which is upside down tan, so tan goes like this, and then the cot graph just does the opposite. But where we've got the 25 here, if we just go 180 plus, that will give us the same part of the graph. So we say that the 3x minus 50 will also equal 180 plus x to get the other solution. And then just again solve for x, take that x over to the side. 2x is going to equal 230, so x is equal to 115 is another solution. And then if we think about the cos graph, the cos of 90 is equal to 0. So if we set x is equal to 90, then it doesn't matter what this bracket is going to be, because we're going to have cos 90 is equal to 0. So the right hand side will be 0. But what about the left hand side? If we think about sine of 90, which is 1. So if we do 1 over sine 90, looking at the cosec, minus sine 90 is equal to cos 90 cot of, doesn't really matter, we can do the 3x minus 50, but it's going to be 0 because we've got that cos 90 there. But on the left hand side, does that work? 1 over sine 90, which is 1 over 1, which is 1, minus sine 90, which is 1, does equal 0. So a 90 degrees is our other solution. This is the last question on the pure section, and we've got this logo and we're being asked to find the perimeter of it, given that the angle AOB is pi minus theta over 2, and that's because we've got theta here in the middle and we've got a straight line which is 180 degrees, which is pi. So this angle here is going to be pi minus the theta, and then dividing it by 2 means that these two angles are the same and we've got a symmetric shape. Now to find the perimeter, because we're in radians, we can have the arc length, which when you're in radians is equal to r theta. So the smaller sectors, their r theta will be r times the angle, which is pi minus theta over 2, and we've got two of those, so that would be those two curved bits there. Then we've got the larger arc length, which again is going to be r theta. The theta is theta, but the r in this case is 2r, so then that's going to be 2r theta, and then we just need to add on the straight bits. There's an r here, an r there, and two r's across the bottom, so that's plus 4r. So adding all that up, these twos will cancel. We're going to get r times pi minus r theta plus 2r theta plus 4r. So we've got minus r theta plus 2r theta, so altogether it's going to be r pi plus r theta plus 4r. Next, we've got a couple of stats questions. We've got a dentist who past records 10% of the customers are late. We've got a random sample of 50, and we're being asked to write a null hypothesis given that the manager believes there's been a change. So we don't believe it's above 10% or below a change. Here the wording of the question means we've got a two-tailed test. So we'd say x is binomially distributed, you're either late or you're not, 50 and p, and then we can say our null hypothesis H0 is that P is equal to the 10%, 0.1. H1, because there's a change, then P is not equal to 0.1, which means we're doing a two-tailed test. And then we can assume H0 is true. So then x will be binomially distributed with sample size 50 and a p of 0.1. That means we think 10% of the 50 people are going to be late. So that means we're expecting 5 to be late. So how far either side of 5 does it need to be? How far away in order for the probability of that to be happening be less than the 0.025%. That is the 5% split at either tail, because it's a two-tailed test. So if we just go on the tables or on our calculator, if we find the probability that x is equal to 0, that's the critical region on the lower end, because that comes to 0.0052. The next one above that takes us out of the critical region because it's bigger than the 2.5%. And then in the upper region, if you do x bigger than or equal to 10, that would be 1 minus the probability that x has to be less than or equal to 9, and that comes out to be 0.0245. So these are the critical regions. If we have x is equal to 0, or x is bigger or equal to 10, or from 10 up to 50, if we have that many people late, then that would cause us to be rejecting H0 because it's so far away from what we were expecting. The actual level of significance is just the two values that we've calculated added together. So that's 0.0052 plus the 0.0245, and that comes to 0.0297. So it's not near the 5%, but that is the actual level of significance. Now, the next part, the manager believes that 15 of the 50 customers arrived late. Comment on the manager's belief. Well, 15 is in the critical region, so evidence to support the manager's claim. The next question is a probability question. We've got G, the event that somebody reads a magazine about green issues, E, equality, S, sports. We're told that the probability of somebody reading all three is 0, so that P is equal to 0 there in the middle. We're told that the probability of the green readers is 0.25. So if we just add up the 0.08 and the 0.05 together and take them away from 0.25, Q comes out to be 0.12. And then we're told, given that S given E is 5/12, find the value of R. So we can use the formula for conditional probability. The probability that S given E is equal to where do those two intersect divided by the probability of E. So S intersection E, because the P in the middle is 0, is just R. So that's R over the probability of E, which is, if we add all these up, is 0.14 plus R, and we're told that that's equal to 5/12. So we just cross multiply. 12R is equal to 5 times 0.14 plus R. Multiply that in. 12R is equal to 0.7 plus 5R. Take the 5R over. 7R is 0.7. So R is equal to 0.1. This next question is on mechanics. We're going to be taking some moments, but first of all, we've got this uniform rod which has a mass m. Now, if it's uniform, that means the center of mass is where the weight is distributed. So we've got mg acting down. A particle of mass 2m is attached at C, so we've got 2mg acting down there at C. The rod is held at A on rough horizontal ground, so because it's rough, we're going to have some friction. We've got equilibrium with an angle of theta, and the string being attached at the end of the rod at B. Well, we're going to have some tension there. Explain why the frictional force acting on the rod acts to the right on the diagram. Well, if this tension became slack, then the rod would slip this way, so friction is going to act to oppose the motion, and it's going to be that way. But if you look at the forces on the diagram, they're made up mostly of horizontal and vertical, but we have got the tension here which is perpendicular to the slope. So if I resolve the tension parallel horizontally and vertically, it's going to go this way and this way. That's vertical and horizontal. Then this horizontal is going to oppose this horizontal. This horizontal one in the tension acts to the left, so the friction one, because we're in equilibrium, will have to act to the right. The next part of this question, we're being asked to show that T is this expression here. We've got A mg B theta. A is a constant, but B is a function. So let's put the forces back on the diagram. We had T, the tension. It was a uniform rod, so we had mg acting down. There was a mass of 2m, so we've got 2mg acting at C. We had a reaction force from the ground, and we had some friction. Now, in order to get an expression for t, we're going to take moments about A. So moments measures the turning effect that these forces are having on the rod. Now, the forces that are acting at A, where you're taking the moments, they do not have any effect on the turning of the rod, so we can just ignore them. And then the component of the mg and the 2mg that will affect the turning is just the component that is perpendicular to the rod. So resolving perpendicularly and parallel, both of those, and then the only component we're interested in is the one that's perpendicular. These angles here are theta at the top, and this is going to be mg cos theta, and this one will be 2mg cos theta. Now, when we take moments, we measure the distance that that force is away from where we're taking moments, and that is A, because the whole rod was worth 2A. C was at 1.5A, and then T is obviously at 2A. So the perpendicular components, they're going to be turning it one way and the T the other. They are equal and opposite, and you take the moments by saying how far it is away from where you're pivoting about times the perpendicular force. So it's going to be A times mg cos theta plus 1.5a times 2mg cos theta. They're both acting down, and then the t, which is already perpendicular to the slope, is acting the other way, and that's 2a away, so it's 2at. So all we need to do is times that 1.5 by 2, and we can cancel throughout by a. So 2 times 1.5 is going to be 3, plus this one is going to be 4. mg cos theta is equal to 2t. So just dividing by 2, 2mg cos theta is equal to t. So my a is 2 and my function is cos. The next part of the question is asking us to find the magnitude of the vertical force extended by the ground. So let's put the forces back on. This is what we're trying to find, the R. We've got our friction, we've got our mg and our 2mg. Now we're told that cos theta is 3/5, and we just worked out that t was 2mg cos theta. So for this thing now, because we're trying to find R, we're going to do forces up is equal to forces down. So the forces up are the R, and then we can resolve vertically and horizontally the T. Now, in order to work out where the angles are, if I put the alternate angle and make a Z here with theta, this one will be theta. This angle here is 90 minus theta, which, because they've got a right angle here, that makes this angle here theta. So opposite is going to be t sine theta, and then adjacent is t cos theta. Now forces up, forces down. We're interested in the force going up, which is R, and the other one going up is plus t cos theta. They're equal to these ones which are going down, which is 3mg. Now we already know that t is this, so R plus t, which is 2mg cos theta, times another cos theta is equal to 3mg. And then given that cos theta is 3/5, we can say that R plus 2mg times 3/5 times 3/5 is equal to 3mg. So R plus 3 times 3 is 9/25 times the 2, so it's going to be 18mg/25 is equal to 3mg. So R is equal to 3mg minus 18mg/25, and 3 is 75/25. 75 minus 18 is going to be 57 mg over 25. So A is going to be 57 and B is 25. Last part of the question, we're just being asked to now calculate mu, which is the coefficient of friction. So if we put our friction back on, our friction here, and friction is equal to mu r. Now what we're going to do is put the tension back on and now just equate, because we're in equilibrium, the horizontal forces. So the only other horizontal force is the component from the tension. So resolving that vertically and horizontally, this horizontal one is T sine theta. So this force and this force friction are equal and opposite. So mu r is equal to T sine theta. Now in the previous part we were told that cos theta is equal to 3/5. So we just put that on a right angle triangle. If the adjacent is 3 and the hypotenuse is 5, then that makes the opposite to the angle 4. So sine theta is going to be 4/5. In the previous question we had that r was equal to 57 over 25 mg, and we had that T is equal to 2 mg cos theta, and cos theta is our 3/5. So that's going to be 6 mg over 5. So if we put them in, mu times the 57 over 25 mg is equal to T 6 mg over 5 times sine theta, which is 4/5. So mu is going to equal, timesing these together, 24 mg over 25, and divide by r, which is 57 over 25 mg. The mg's will cancel, the 25's will cancel, and mu is equal to 24 over 57, which cancels down to 8 over 19. Thank you so much for watching. Hopefully this has helped a little bit with your Christmas revision, getting you ready for your mocks next term.